Hi everybody, welcome to our session on SQL Server Containers where we're going to be talking about SQL Server Containers for the next hour and share with you what we've been working on. Now before we get started, just a few announcements from the PAS side. At PAS Summit, it's more than just the sessions. There's also a lot happening throughout this PAS Summit online, so do check out everything that PAS has to offer at pas.org, as mentioned on the slide. And we are also, something that's really important to us is also the session evaluation. We are trying to do our best by presenting our session digitally, but anything that we are doing well, do let us know, and anything that we can improve on, also let us know. Thank you. And my name is Vin Yu. I'm a program manager that's primarily been working on the SQL Server and Linux containers and Arc data space. And you could reach out to me and connect with me at my Twitter and my LinkedIn, which is also mentioned on this page. And joining with me today is Amit. Amit's going to be presenting himself later in this session, where he's going to talk about some of the new innovations that's coming in SQL Server containers. And you can connect with him on his LinkedIn and his Twitter with the things you see on the screen here as well. So for the agenda today, we're just going to start by sharing some of the background of SQL Server containers, why some of the deployment for SQL Server containers, and what's new, and just some of the new deployment options that we have available since we last talked. And then we're going to go into some SQL Server container scenarios. And then we're going to also share with you some of the new features and demos that we've been working on in the container space. And we're going to close out with this on the next steps on how you can try out some of these things that we showed in our demos today, and close it out with some Q&A. So why SQL Server containers? So, I have been presenting SQL Server containers a little bit throughout several conferences. I think I did speak at PAS last year or the year before about SQL Server containers, but I still get a lot of questions and interest about, hey, why would I want to use SQL Server containers? For starters, I like to just bring out some of the few things about containers. Is first of all, it's portable. SQL Server Containers ships with all its dependencies packaged together side by side the actual SQL Server application. So no matter where you go, you could take that SQL Server container and deploy it to your cloud environment or on your on-prem environment all the same way. Second of all, there's no installation. The SQL Server bits is already laid out inside the container and ready to run. So think of it as kind of like a zip file. Once you unzip that file, there's an exe, and you could just go ahead and start that application. Next of all, secure. We have been doing a lot of work this over the past year on security, and I'm going to let Amit talk about that shortly in a bit. And I'm really excited for some of the things that we've been working on. Next is ease of use. We're going to also demonstrate to you how easy it is to take a SQL Server container, start it up, spin it down, and use it from dev to test, and even in some production scenarios as well. Next, it's configurable and customizable. So we're going to talk about how you can configure some SQL Server containers as well as customize a container, such as taking SQL Server and using it with a container platform of your choice, whether it be running it in a Ubuntu or RHEL environment, or turning on certain configurations such that your container starts the same every single time. It's possible, and we're going to talk about that later as well in the session. And last but not least is maintain state. And I like to bring this up because a lot of customers ask, well, how do I persist data? How do I persist some of those configuration settings inside my container? This is all possible inside containers, and this is why I wanted to bring this up as well, because this is a very common question that I get asked a lot. And I like to next share with you some deployment options. A lot of times when we think about containers, we really just think about Docker. And if you look on the screen, there's a little containers at the very top. You'll notice that typically when we do a Docker run or a Docker stop of a container, we're really just talking about a really small slice of where you could deploy containers. And that would be just deploying it on your client machine on a Linux bare metal deployment. One really big area in which our customers do deploy containers is through a Kubernetes-like environment, which is with a container orchestrator. So you see that whether you choose to deploy on Kubernetes or on OpenShift, there are many different options. Even amongst Kubernetes and OpenShift, there are on-prem and cloud infra offerings that's available. For example, if you want to run SQL Server containers on the cloud in Azure, there's possibilities where you could run it in AKS. And if you want to run it in the cloud with OpenShift, there's managed OpenShift clusters such as uh, ARO. Right, so all this is possible. There's really a growing number of options where you could deploy SQL Server containers, and this is a pretty big area of ours here. So just a short history of SQL Server containers. SQL Server containers are still a fairly new product relative to many things. So if you look at, just yet, before prior to 2017, where SQL Server only ran on Windows and containers were not really a thing, that wasn't possible to run SQL Server containers. Starting with SQL Server 2017, we bought SQL Server to Linux, and this also brought the first SQL Server container. Right now in 2019, in that 2-year span, we actually used SQL Server containers to build new products such as big data clusters, and with that, we also brought many container improvements, such as non-root by default to make it more secure. We also made it work with Red Hat environments, amongst other improvements. And today, if you look at it, we're going to continue to use containers as a foundation where we're building new products such as Arc Data Services, and we'll continue to improve on big data clusters, and we are continuing to even add more improvements. So today you're going to see some demonstrations which Amit's going to show you on AD, on more security features. And one thing I like to just bring up is containers are not going away anytime soon, right? So if you look at tomorrow, one thing at the very end of my timeline here, we're going to continue to use containers to build more products. We're going to continue to add more features to the SQL Server containers ecosystem as well. And with that, I'm going to pass it to Amit, who's going to take on the next section where he's going to share with you some scenarios, as well as share with you what we've been working on and demo those environments as well. On to you, Amit.
Thank you, Vin, for sharing the stage. Hi, everybody. My name is Amit Khandelwal. I'm a senior program manager with Microsoft, and I'm here today to talk to you about the work that we've been doing with SQL Server containers. I'm sure Vin has taken you through the journey for SQL Server containers, how we started in 2017, where we are today, and what we are going to do about it tomorrow. And he's also given you the options about the deployment options that you have. I want to take it from here, where I want to really talk about the SQL container scenarios that we've seen our customers use SQL Server with. So as you can see in the slide, I'm going to talk to you about some of the SQL Server container scenarios that we have seen customers implement in their environments. Now, again, these are just the sample scenarios that we've seen. And what I've done is I've only picked those scenarios which has the highest number of implementations in the environment. There are more scenarios that you can do with SQL Server containers. Honestly, it all depends upon the imagination that you have, and based wherever you would like, SQL Server containers can be made available for you there. So let's get started with the container scenarios and see what it is all about. So the first scenario that we've seen SQL Server containers being used maximum by our customers is in the area where they want to run multiple instances of SQL Server in their environment. So imagine that you have, like today in SQL Server Windows, when you run a SQL Server instance, most of the times you would probably have more than one instance running on that same SQL Server Windows host. The same is not possible right now with SQL Server on Linux. With SQL Server on Linux, you can only have a default instance of SQL Server that is running. But with SQL containers, you can now run multiple instances for production, for reporting, all of that on one single Linux host. That option is available with SQL Server containers, where you can run multiple containers, which is nothing but multiple instances of SQL Server running on that single host. Now that's made possible with SQL Server containers. So imagine in your production environment, you have a one OLTP environment where you have maximum number of resources associated from that host to that SQL Server container. Then you have on that same host, you have a reporting instance of SQL Server, and you can limit the resources that you give from that host to that SQL Server instance as well. And I'm going to show you a demo of how you can create or deploy SQL Server containers with limited resources that you can pick and choose from your host. So that option is where we've seen customers use it. The second option that I've seen most of our customers use this is in a situation or in an environment where they want to provide database as a service to their own organization. So I'm sure in your organization also there must be multiple teams, multiple people working on different projects, and each project would like to have its own containers. Especially in this world of microservices, you would want your application to deploy its own SQL Server container or to deploy its own database environment, which in this case is SQL Server container. And the problem that was there before containers was that you could always have each project associated with a specific database on a single instance. But in that case, quantifying the amount of resource taken by each database within that instance was always tough. For example, let's say you want to identify how much of CPU and how much of memory is being utilized by database A out of the 10 databases that you have in one single instance of SQL Server. That quantification was really, really tough with SQL Server, with at the database level. What we do with SQL Server containers is we make that quantification really easy, because what you can now have is for each project or for each group of people who are working on one single project, you can have one single SQL Server instance running one single database. For another group, as soon as they want to create their own application, they can then go ahead and instantiate another instance of SQL Server or another container, in other words. So this way, each project or each team is now working on their own SQL Server instance, isolated from the others. And because you're running at an instance level, it's easier for you to identify the CPU, the memory, and quantify these resources to that specific instance. That option of making database as a service is now available with SQL Server containers. So this is another big scenario that we've seen customers really using SQL Server containers in their environment. The third scenario that I want to talk to you about, the first two scenarios were very production environment specific. The next two scenarios that I want to talk to you about is where I've seen customers use SQL Server containers at maximum levels, which is in their UAT and dev environments. So what they basically do is, imagine you have an application and you've made changes to that application, and now you want to test those changes against multiple containers that are currently running, or you want to test those applications again multiple instances or versions of SQL Server. That is made possible very easily using SQL Server containers, because you can deploy SQL Server containers within seconds of different versions on the same single host, and then run your application changes that you've done against those different instances of SQL Server. And all you can do this in less than few minutes, because you can deploy containers in seconds and get started with your testing. The other place that we've seen a lot of implementation is in the CI/CD pipeline. So you want to take your database and integrate it with your continuous integration, continuous development pipelines like the Azure DevOps or any of those CI/CD pipelines. SQL Server is ready as a database for you to start it and plug it into your CI/CD environment. So what I'm basically saying is, imagine someone goes ahead and clicks on the build button for that pipeline, and with the build, the database gets instantiated in the backend. And once you've finished your work, you can go ahead and delete that database on its own. So all of that is taken care in your CI/CD pipelines. That's another place, or that's another scenario that we've lit up using SQL Server containers. So again, as I said, these four specific scenarios that we spoke about are only specific to the ones that we have seen. But again, you can use SQL Server containers the way you would like to use, and there's nothing that kind of stops you there. In fact, all the features that are currently supported on SQL Server on Linux is also supported for SQL Server containers as well. Great. Hope I was able to give you some of our experience in terms of what we've seen customers do with SQL Server containers. Because let me also tell you this, that we already have about 11 million instances active running on SQL Server containers. So there's been a lot of work that people have already started doing with SQL Server containers. All right, I now want to spend some time talking about the features or the work that we've been doing for past 1 year on SQL Server containers to make it production ready, to make it something that you can take it and run in your production environments without the fear of being, whether it's a secure deployment, without the fear of will I get all the features that are required for my SQL Server containers, all of that. The first thing I want to talk about is the non-root containers. Now, starting SQL 2019, by default, when you deploy your SQL Server container, 2019 containers, they run by default as non-root. Now, this is really, really critical, especially in those environments where you have those regular audits checking for your container deployments to ensure that containers are not running with root privileges, because containers that run with root privileges normally becomes a vulnerability that can be misused by any hacker who's trying to get into your host through the container. So the first important security principle when you're running container environments in production environment is that you need to run your SQL Server containers as non-root so that they don't have any extra privileges over the host. And that's what we've made as the default option when you start deploying SQL 2019 containers. And I'm going to show this, all these features that I talk about. We are going to take a look at all of these in our demo section of the which we are going to probably start. We are going to start next slide. The second thing, again, related to security is if you have SE Linux enabled, which is security enhanced Linux modules enabled in your host, we currently respect that. And what the containers, the SQL Server containers can run on a host which has SE Linux enabled. So let's say that you have your SE Linux running in an enforcing mode. In that mode, when you run SQL Server containers, you can run SQL Server containers, and the container runtime does get the all the SE Linux properties loaded into that. So SQL Server supports running on SE Linux enabled host. The third most important aspect that we've worked upon securing your SQL Server is enabling TDE and enabling SSL encryption. Now, you must be aware that in SQL Server, or as per the GDPR law, you need to have your database, your data encrypted at rest, as well as data encrypted when it's in transit. Now, for SQL Server, those two options are enabled using TDE, which ensures data at rest is encrypted, and SSL encryption, which ensures that the data in transit is also encrypted. And both these features, again, I'm going to show you a demo of this. Both these options are available in SQL Server containers. So when you deploy SQL Server on Linux containers, you can go ahead and enable SSL. At the same time, you can also enable TDE environments on top of it. The other part which I really want to talk to you about, when mentioned to you how easy it is to get started with SQL Server, how easy it is to get, to start running with SQL Server. What I also want to tell you about here is that it, even though all of this is easier, it's not like one size fit all that we bring in. You want to customize your SQL Server. Let's say you want to run SQL Server on SLES environment, and we don't ship right now containers on MCR that you can pull, which are running on SLES. So what you can do is you can create your own container. There are certain boundaries in terms of customization, and I'm going to talk about those boundaries as well. But within those boundaries, you can definitely do all your customizations in terms of enabling features, running it on your own OS, your OS that is currently supported as a distribution for SQL Server on Linux. You can go ahead and create your own customization for those SQL containers. So you can do all of that. And I'm going to show you a demo where I'm going to use a Docker file, create a SQL Server container image on top of SLES and show you how you can start running Docker containers out of that. The other part which I want to talk to you about is also limiting resources. Now, when you can run multiple instances of SQL Server in your environment, you need to have a control where you can limit resources. For example, you need to have a control where you can say, I want to run my SQL Server container with, let's say, 3 GB of memory and let's say 2 CPUs. Again, that's a really small environment that I'm talking about, but just for the sake of our discussion, we can do that. You can limit the amount of memory that you're actually using for SQL Server. At the same point of time, you can also limit the CPU that you're using for SQL Server containers. And you can so on a single host, if you have a lot of resources, you can distribute those resources as per your liking, as per your requirement between different SQL Server containers that are deployed on that single host. That is also possible. Now, another feature which has been the most weighted feature so long for about a year is what I want to talk about. Is the big question that I always get in my customer discussions is, does SQL Server container support AD authentication? And the answer to that is yes, it does. And to make life easier, or to make that configuration easier, we have now previewed a new tool which is called as the Adutil tool. I'm going to talk about the Adutil tool in the next slide. But what I really want you to take away from this slide is that today, or since this talk that I'm talking about, from today onwards, you can go ahead and configure AD authentication on SQL Server containers very easily using Adutil tool. So Adutil tool basically goes ahead and makes your configuration experience, the configuration experience of enabling AD authentication and SQL containers very seamless. You don't have to switch between Windows, between Linux to create a user first using PowerShell and then come back and go back to your CLI and start working with the users. You don't have to do all of that. From one single CLI command prompt, you can create a user, you can create the SPNs, you can go ahead and create a key tab file, and all of that options are made possible. In fact, let me go one step ahead and say that for SQL Server containers, for you to enable AD authentication on SQL Server containers, the host does not necessarily require you to join the host to the Active Directory domain. So the host can still be sitting outside the domain, but you can still have a service, which is a SQL Server container, which is running the service still connected to the domain. That is also possible, and that makes life easier when you're deploying SQL Server in Kubernetes or different container orchestration environments. So you can do that, and you can use Adutil for both Windows and Samba domain. And in fact, because Adutil is CLI based utility, for all you Linux users who who is very accustomed to your Linux CLI, you can sit there and manage your Windows domain from using the Adutil tool. So that's the impact of Adutil, and that's what you can basically do. So I think we've spoken enough. I think now it's time for us to see all of this in demo. So let's go ahead and let's jump right into it and get started with it. So let me know if you can see my screen. Let me just switch to my screen here. Just give me 1 minute, and let's go here. So I hope you all can see my screen here. So this, let me just increase the font here for a second so that it's all visible. All right, with this, let's go ahead and start our demo. So I am right now on a Linux machine, which is running RHEL 8, and I have already downloaded the Adutil tool, and the download instructions for the Adutil will be available. When I'm doing the demo today, this is the latest version of Adutil, but probably when you will start working with it, the version would have changed. That should be okay. That should not be a problem. And what I want to talk to you about is first introduce you to the environment. Now, this is a machine which is already part of the domain. As you can see, when I do a realm list, you can see the domain name being mentioned here. So it's already part of the domain. I am going to run my container on this machine, which is called as rel no domain. So the name is probably gives you a hint that this is not joined to any domain. So right there, you can see I did a realm list. It's not joined to any domain. So what I'm going to do is I'm going to run a container on this machine, the rel no domain machine. And when I'm running the container is going to be joined to a domain. So the container will support AD authentication, but the host is not part of the domain. All right, now let's see how can I get started with it. The first thing that I told you about Adutil is you can use this utility to go ahead and create users, create SPN. So let me tell you what we are going to do in this domain. The first thing that I'm going to show you in this demo is using Adutil. I'm going to create a user in my Active Directory. Then I am going to create an SPNs under that user. And then to link all of this together, I'm going to create a key tab file, which is going to have the SPN and the user details created again on this machine, post which I'm going to copy the file that I created, which is the key tab file that I created from this machine, the rel2 machine, to the rel no domain machine, so that I can load my key tab file to the container. In the same demo, what I'm also going to show you is how you can go ahead and encrypt the connections coming to the SQL Server. So I'm going to show you both of these, demos together. Also, what I'm going to do is to enable SSL encryption, I'm going to create a self-signed certificate. Now, for this demo, I'm creating a self-signed certificate, but for production environments, that's not recommended. What is recommended is you get a third-party certificate to use for encryption, like you would do it for Windows. Great. So with all that said, let's go ahead and start working with it. The first command that I want to show you, hopefully you can see my screen, is realm list, and you can see I'm part of the contoso.com domain. And let me just increase the font size to ensure that you all can see it. Great. So now what I'm going to do is, as I said, the instructions or the commands to install Adutil will be shared. So right now, this is the version that I'm using. The first thing that I'm going to do is I'm going to create a user called as SQL Pass user. And what I'm going to do here is you can see I've given the name for the user. This is the user that I'm going to create in my Active Directory. Then I'm going to go ahead and also provide the distinct name, which basically is the name of the user, the organizational unit where I want to create, the domain name, and all of those details. And then I pass the password for this user. Again, for the purpose of demo, I'm passing this password in plain text, but what is recommended is you don't pass it in plain text, but probably you can pass it interactively, to the Adutil. So you can do it interactively, or you could also pass it through a configuration file, anything that works best for you. Now, before I'm not going to run this command because I've already done that to save time. So once you run this, this is going to go ahead and create a user in Active Directory domain, which you can find in your AD. And then what I'm going to do is I'm going to go ahead and create the SPNs. Now, before you run Adutil tool, one most important thing that you need to check is you need to kn it into your machine. Right now, I have already done that. So you can see, I can see the different tickets that I currently have in my cache. So I have created the user now. The next step that I'm going to do is create an SPN. And to create the SPN, all I've got to do is run this command add util SPN, add auto, as you can see. Now, when I say add auto, I need to provide the host name, which should be the fully qualified domain name of the SQL Server container. Now, I am going to give the container that I'm going to create on my rel no domain machine is this with this name. The SQL pass is going to be the name of that container. So I'm going to go ahead and create this one over here, and SQL pass is the name of my container, not the name of the host. Okay, and 5433 is the port number that is going to be mapped on the host with the SQL Server container. So this is what I'm going to do. Again, I'm not going to run this command because I've already done this. To see the SPNs already created, I can just run a command like this, where I can say the name of the user is SQL pass user. There's a typo there. As you can see, the SPNs are already created. These are the SPNs that I've already created. These are the SPNs for the container that is mapped with this particular user. So I've created the SPNs, I've created the user. The next thing I've got to do now is create the key tab. Now to create the key tab, the command that I'm going to use is this. So this is a key tab that I'm going to create in the location here, which I'm already part of, which is my working directory right now. And the username to whom I want to map this is the SQL pass user. And then I provide the password. Now, when I hit enter, I'm just going to hit enter, but not create this. It'll ask me the encryption types that I want to use. You can choose more than one encryption if you'd like. But you need to choose those encryption types that are supported in your environment. For example, I know AES 256 and ARC4 HMAC, both of them are supported. So if I have to choose more than one encryption types, I just give the values and then hit enter. This is going to create the key tab. I'm not going to do that because I've already created it before we started the demo. So I have once I create the key tab, what I need to do is also create the key tab for the SPNs that was created. So the command for doing that is here. As you can see, I say adutil key tab create auto, the same location or the same key tab file, because when you add anything in the key tab, it's an append that happens, not an update. And then provide the fully qualified domain name of your container and ensure the passwords that you pass are the same for the user, because this is the same user password that you need to pass. Again, please don't pass the passwords in the plain text like I've done. This is just a demo, that's why I'm doing it. For production, please do follow the recommended practices of using interactive password method or using the configuration file. So once I do all of this, it's going to go ahead and create the MS SQL key tab. And then for SSL encryption, I'm also going to go ahead and show you the command that I used to create my MS SQL key and MS SQL.pem files. Now, these are the files that are nothing but your certificate and the private key associated with that certificate. And because SQL Server supports RSA keys, that's why I've used an RSA key. The most important part of this is, again, when I'm creating the subject name for my certificate, it should match with the fully qualified domain name or the name that you're going to use in your SQL, in your client connections to that SQL container. So sqlparse.contoso.com is the fully qualified domain name of my container that I'm going to use in my client connections when connecting to it. So once I do all of this, you would see it is going to go ahead and create the MS SQL key, MS SQL key tab, and MS SQL PEM, which is the certificate, the private key associated with this certificate, and the key tab for my AD authentication. Please remember, key tab is required for the AD authentication. The mssql.key and mssql.pem are the certificate and the private key for that certificate, which is required to encrypt my connection to SQL Server. Great. So what I do, I have created all these files on a machine which is already connected to the domain. Now you can go ahead and then copy the MS SQL key tab file, which is created from a machine which is on the domain. It's not necessary for you for encrypting SSL and for encrypting connections to SQL Server. It's really not necessary to create MS SQL PEM and MS SQL key files on the host which is connected to domain. You could definitely go ahead and run OpenSSL command here and create the files here. I just did it for the sake because I was just on this machine, so I just created here. So I copy all these three files onto my other machine. Again, let me just increase the font here to ensure you can all see the font in the recording. So now what I do is I just do a realm list again, just to show you this is not connected to any domain. I have copied my files, the MS SQL key tab file, the key file, and the PEM file over here, which were all created from the machine, which is part of the domain. Now to run my uh, uh, container, the command I'm going to use is podman run. Now let me do this. Let me just clear this file and run the command here, just so that I can take you through what each of this command is doing. So I'm just going to show you here. So please look at the screen here to understand what I'm actually doing. Right now, what I'm doing is I'm saying podman run, which is deploy a container for me with these environment variables. Again, please do not pass SA password the way I've done it. If you do, after you create the container, the first step that you need to do is connect to your SQL Server container using SA password and change the SA password using tsql alter SA password options. Then what I'm going to do is map my port to the port which is running SQL Server container. So on the container, SQL Server is listing on 1433, but I'm mapping that to 5433 port on the host. Then I give the container name. This is the name of the container. Then there is -h parameter where I provide the name of the server or the host name. So if you connect to that container and run select at that server name, this is the name that's going to be returned to you. Now, the next set of commands that you see here highlighted, which I'm doing, is a volume mount of the container, and I'm mounting the MS SQL to the SQL pass folder on my container. And then I'm also mounting the curb config file. I'm also mounting the MS SQL PEM file to this location on the container. And then I'm mounting the key file as well to this location, so that when the SQL Server container starts, it's able to identify these files and set up the environment accordingly. Now, because I'm running all of this in Azure, I need to add these options as well to ensure that I bypass the DNS of Azure and connect to the DNS servers mentioned here. 10.0.0.4 is the DNS or the domain controller in my environment. So now when I run this command, this is going to start a container now, which is called a SQL pass, as you can see, because that's the name I've given to the container. Now, before I go into the detail, I really want to show you what I have in my MS SQL config file so that I can enable SSL and I can enable Active Directory authentication. So the first thing that I have in my, let me just clear this again, so I have more space here. And let's just go through the MS SQL config file. As you can see, I have these four settings that I've highlighted. This is required to enable the SSL setting. And these two lines that I've highlighted here is required for enabling the Active Directory authentication. So please remember, I'm doing both Active Directory authentication and SSL encryption in the same demo. That's why this is the config file that looks like. Now, if you remember in my podman run command, I also had the curb5.config file, which basically was mounted to the container. The reason I mounted that to the container was so that my container, my curb5.config file has the information of the domain controller. So if I just show you the config file, it's basically the information of domain controller and where my KDC lives, the name of my host. So with this information, what I've basically done is I've set up my container to ensure that it's going ahead and able to pick, it's able to pick these files and load and mount them here. Now, another important aspect that I wanted to show you in this is with every mount, I have specifically used this option :Z or :Z as they call. Now, why have I used this option? As I said, SQL Server containers do support hosts running SE Linux. Now, if I have to check the SE status on my box here, you will see it's currently enabled as, and it is in the enforcing mode right now. So SE Linux is enabled. Because SE Linux is enabled, I need to ensure that the labels for this volume is such that it lets my container write into these locations. And that is why I'm using :Z. If I don't use :Z, then this container is going to not start and it's going to fail on machines which have SE enabled. So you need to ensure that the labels match, or the labels allow you to go ahead and write into the host container files. So with this, let me just see the status. My container is currently up and running. So let's go ahead and load the certificate into this box so that I can go ahead and encrypt my connection. This is my client right now. So what I've done is I have imported my mssql.pem file in the trusted root certificate authority. And to load the certificate, all I did was I first copied the mssql pem file into this folder, and then I can just go ahead and import this particular certificate, as you can see on the screen. Once I do next and I click finish, it's going to load the certificate, and I've already done that over here beforehand. So the certificate is all up and loaded. What I've also done is I first will go ahead and connect with the SA authentication, right? And look here, I have enabled the connection as encrypted. And when I hit connect, it goes ahead and connects to it. And then I can go ahead and create a login, which is a Active Directory login. This is a domain login, which is there. This is a Windows login. I'm just going to go ahead and create this. Once I create this, I can quickly check under the logins, the account is created, and then go back here, change to Windows authentication, again, encrypt the connection and connect to it. Remember, sqlpass.contoso.com is the name of my container, and bingo, there you go. You have an Active Directory authentication working for SQL Server container on a host which is not connected to the domain, but the SQL Server container is. And please remember, the name of your container should match the certificate so that your encryption, the SSL encryption works for your SQL Server. So with this demo, I want to show you how easy, with 5 steps with Adutil, I created a user, I created a SPN, created the key tabs, copied over the files to the other box, created an MS SQL config file to tell what was my privileged AD user and to tell where my key tab files are, and then mounted those files on top of the container and just started the container. And here you go, I have Active Directory authentication enabled. So as you can see, with less than 5 minutes, I was able to go ahead and create and enable Active Directory authentication working for SQL Server containers with SSL encryptions also enabled. And all of this on a host which has SE Linux also enabled. So you are completely in a secure environment. Now, before after this, the other quick demo that I want to really show here is about the non-root containers that you have. So as you can see, I have a container which is running right now over here. Sorry, wasn't on the wrong machine. So as you can see, I have a container which is running right now, which is SQL Pass. So let's say, let me go ahead and connect to this SQL Pass container. So when I want to connect to the SQL Pass container, I'll go podman exec -it SQL Pass, and then I open a bash command. And then if I type a simple command as who am I, you can see I'm inside that container. Inside that container, I opened a bash command. And when I typed who am I, you can see it's an MS SQL user, which is the non-root SQL Server user, which gets created when you create containers. So I am currently logged in as a non-root user, non-root container. And this is exactly what I was talking about when I said the containers run in non-root user. And that's what you see over here. Great. Now, you've seen this. Now, another information that I really want to share here is you can always, because I'm on RHEL 8 machine, I'm actually using Podman, but you can all do this with Docker as well. So I can simply go ahead and create a simple alias here, which is saying Docker equal to Podman, and then just do Docker ps minus a, and it works. So at the backend, it's Podman again working for you, but RHEL 8 right now supports Podman on this and not Docker. So what I want to show you with this is that even if you go ahead, your SQL Server containers, you can work whatever demos I'm showing you here, they work exactly the same even for the Docker scenarios as well. So you don't really have to limit yourself with just Podman. I mean, you can use any OCI compliant tool and start working with SQL Server containers. So now what I want to show you is how you can limit resources for each of the containers. The first thing that I'm going to show you right now is when you start a container without limiting any resources, it takes complete resources that are available on the host. And then I'm going to also show you a way of how you can limit resources and start a container. So what we're going to do is, hopefully you can see the screen. The first thing I'm going to do is podman run command, where I'm actually not going to give any limits to the resources. And what this is basically going to do is going to use all the resources that are available on the host right away. So when I run this command, you will see the SQL Server is going to deploy a container. And when I just go ahead and look at the logs, which I can do using this command, which is podman logs, the name of the container, give a space, and then let's say I just want to read the first 35 lines. Now, as you can see, I have about 16 GB of memory on my machine, and right now SQL Server is using about 12.6 GB. I think it's not 12.6, it's probably 12 GB. Out of 16 GB, it's using all 12 GB. Now, the reason it's just using 80% of the overall memory is because by default, when you start SQL Server, it's not going to use all the memory that's available on the host. It's only going to use 80% of the host memory. And you can change that behavior using MSSQL config option. But what I really want to tell you is right now it's using 80% of the entire memory that I have on my host. Now, let me show you a way where you can limit this resource, not only in terms of memory, but also in terms of CPU. So to do that, I'm going to show you a command, which is sudo podman run. And here you can actually see I'm creating a new container called as SQL memory cap. And I'm going to limit my memory to 3G. So when I run the same logs command, what I expect to see is that we are only using 80% of 3 GB, which is about 2.4 GB. So let's see if this is true. So now this container is deployed. Now let's just look at the logs for this container as well. So which is podman logs, the name of the container, and then let's say I just again want to see the first 35 lines of the logs. Now, as you can see, bingo, there we go. We have specifically limited our resources and we've given only 2.5 GB or 3 GB of memory to this. Now, if you want SQL Server to use all the 3 GB, all you have to do is create an MSSQL config file like I showed you in the Adutil demo, and then start, give SQL Server to use the entire memory that's available. So with this, you can now see I can limit CPU, I can limit memory, I can limit basically the resources that are there for each of the containers. Now, what I want to show you is another demo where how you can create your own configure your own container from the scratch. I don't want to download anything from using the pull commands, but rather want to create my own container using a Docker file. So now what I'm going to do is I'm going to switch to my slash machine, which is a SUSE machine. And what I've done here is I've already created a Docker file, and what the Docker file basically contains is I am downloading a OS image, the first thing. Then I'm going ahead and downloading another package that I need. In this case, as an example, I have used the libcap program, but you could also download any package that you would need apart from the SQL Server. And then I have gone ahead, installed SQL Server and SQL Server tools with the options to accept EULA and interact with non-interactively run the setup. And then I'm going to go ahead and give right amount of permissions on the SQL Server folders to the MS SQL user. And then what I'm doing in my Docker file is using setcap, which is a functionality available in this package. I'm going ahead and ensuring that SQL Server has permissions to connect to all the ports which are less than 1024. And these commands are then going ahead and ensuring that SQL Server as a non-root process can still take a dump. Because remember, all your SQL Server functionalities like the dumps, the error logs, the agent logs, all of that is something that's also available on SQL containers. And then because I've used setcap, it basically goes ahead and breaks certain dynamic links. So I'm just going ahead and setting those up again. And here I'm exposing 1433 as a port and starting my SQL Server from the binaries under the user MSSQL. So this is what I have in my Docker file. And going back to this, I can just show you the same to you in the Docker file that I have. And now if I want to go ahead and create an image out of this, all I've got to do is run docker build command, as you can see, and I'll call my image as /SUSE SQL Tools 1. And when I hit enter, this is going to go ahead and build the SQL Server image. And I can see this image from Docker image and sorry, Docker images is the command. So you can see I have the image created. And what I can do here is, again, I can quickly go ahead and run a Docker command, which uses this image, which I've just created. I think I already have a container with the same SQL one already. So I need to first delete that. So I'll say docker rm SQL1 minus f. This should remove it and then run the same command again. This should work as it is. And now if I go ahead and take a look, the container has started. Let's just go ahead and look at the logs SQL1. And let's say I want to take a look at the first 35 lines of the logs. So it's still starting up. So that's why it's just taking a couple of minutes. So if I have to just connect to this, let's see if I can connect. So I'll just go ahead and run this command over here, give the password, which is not supposed to be typed in. I think I just made a mistake there. Let me just give the password again. So here you go. I'm connected. Let me do select at version. Go. Remember, when I started my container, I've used -hs equal 1. So what I expect an output here is for the version, I expect SUSE server 12 SP5, which matches with the base OS image that I have downloaded. And I've gone ahead and downloaded the latest SQL Server, which is CU8. And when I do a select at server name, you'll actually see the name which I've provided when starting my container. So this way, I have created my own container from the scratch using a base OS image and was able to create it. Now, you can add to this Docker file components like machine learning, DTC, and start working with it. So the idea here is that your SQL Server containers, while it is easy to deploy, while it is easy to use, they are completely secure, they are completely configurable, and something that you can control and start working in your production environments from day one. So with this, I think let's go ahead and go back to our slides. We've seen the demos, so we'll just go back to our slides for the next content. Great. So we've looked at the different options here. Now the next thing that I really want to talk to you about is certain performance specific options that you can enable on your environment so that you can get the best out of your resources that you've provided. For example, if you've not heard the session that Tejas from our team who was given on SQL Server on Linux, where he's talking about different options where you can make your SQL Server on Linux and Azure environments run much faster than what you, with basically with switches using OS, OS level options, using storage level options. All of those options are spoken in detail in his session. So if you've not heard his session, my recommendation is please go ahead and listen to that, because they're really awesome. The same options can be applied for SQL Server containers as well. And this is where I want to talk to you in the slide and show you about the different options that you have. So you typically create your on the host that is running SQL Server container, you need to ensure that you have a tuned profile created with the parameters as shown here. Please don't worry, this is all documented even in our guidelines. They're completely official. So you can go ahead and create this tuned profile, and you make SQL and have your host apply this tuned profile and run SQL Server under this tuned profile, using which all the best OS options or configurations that work for your that provide the required base for SQL Server to run will be provided. And other options like NOA, user time, and all those settings also apply to the host. So the host needs to follow the guidelines given on the slide and needs to have the tuned profile. At the same time, the host or the storage that you're using to mount onto the container to persist the data needs to follow the recommendations of the storage that are listed over here, which is if you don't have FUA, which is forced unit access enabled by default from the hardware, then you go ahead and use forced flush with the settings like trace flag 3982, control write through, and control alternate write through are settings that you can enable using the MS SQL config, which controls the force flush behaviors. And if you have FUA, which is the recommended practice, and mostly with the XFS file system, they are currently most of the devices have this enabled. So if you have FUA enabled and your Linux kernel is 4.18, then on the storage provider or the host which is providing you the storage, these options are something that needs to be enabled. Of course, the SQL Server options will go into the container MS SQL config, but the DPU FUA 1 or DPU FUA 0 are basically the settings that you can get from the storage itself by running some of the commands like lsblock and all of those. So great. So with these performance configurations, you need to ensure that these are already set on the host environments before you run your SQL Server, and the storage configurations are set on the environment which is providing you the storage. So this covers the performance specific part. Now, what I really want to also quickly go through is the basic understanding about this, the support policies for SQL Server. Now, you saw that you can configure SQL Server containers in your own way. There are certain boundaries which I just want to share here so that you're all aware of it. The first thing that I want to talk here is the operating system of the host and the operating system of the container on which you build the base image should be the same. And this is not a limitation from SQL Server, but more so from our partners who kind of like to support on their operating system the same OS, the container image is built on the base OS, which matches the host OS operating system. So that's one option that you need to always remember. The second condition, or the second concept that you need to be aware of is you can create SQL Server container images, and Microsoft is going to support those container images only on those Linux distributions that are supported by SQL Server on Linux. And today, the Linux distributions that are supported by SQL Server on Linux are SLES, RHEL, and Ubuntu. So on these three operating systems, we support SQL Server. So you get complete support. You can go ahead and create your containers on any of these three base images. So you want to create your SQL Server container image on a RHEL UBI image of your choice, you can do that. Or you want to use a public RHEL OS image, you can use that. You want to create on SLES, like I showed you in the demo, you can use that, and all of that is supported. Second, any configurations that you do or any customizations that you do in your containers, please ensure that you do not change anything in terms of the licenses, the directories, the binary directories, because if you do any incorrect modification, that can render SQL Server to not start. So always remember that your customization should not break SQL Server from starting. So that's the only options that you need to be aware of. The last point that is very critical is you can do all the customizations that are required for your SQL containers, but you cannot do customizations that are required for containers to run in Azure Arc or SQL Edge. So for those, you need to run with the containers that are built these products. So with this, that basically gives you an idea of your limitations right now that you have, or the support boundaries that you have for your SQL Server customizations on containers. With this, I really want to touch real quick about how SQL Server works with container orchestration environments as well. Because as Vin said earlier in his presentation, that whenever we talk about SQL containers, the de facto mind or the default setting that we always remember is pretty much that SQL Server runs on Docker and SQL Server runs on Podman. But what I really want to tell you is SQL Server containers run where you want them to run. You want them to run on Azure, Red Hat, OpenShift clusters, it runs there. You want to run them on your custom OpenShift clusters, which are built in your on-premises deployments, it works there. You want to run custom on-premises deployments of Kubernetes or OpenShift on VMs which are based on Azure, and you've created your own custom deployments, it works there. So the idea is SQL containers are completely supported on Kubernetes and on OpenShift 4.0 plus and Kubernetes 1.16 plus. So you can go ahead and start running your SQL Server containers there. Now, the benefit that you basically get with running SQL Server containers on an orchestration environment is that the default HA benefits that is built into the container orchestration, depending upon the deployment YAML files, where you have a specific amount of replica sets created, always that replica set or that deployment is adhered to. For example, let's say you have a deployment where you have a persistent volume of SQL Server, you have a 3-node cluster, let's assume, and you are having a single SQL Server pod running there. If the pod goes down, it will still come up on its own without any user interference, and that is completely supported at this point of time. So SQL Server Containers does support the HA that comes in with the orchestration environment. So this is a pod failure, and you can see the pod is starting on the same node. Similarly, if the node goes down, the pod can also start on another node all on its own. So this entire option is made available and is by default built in into the Kubernetes cluster, and SQL Server kind of supports that. So what I really want to show you is I want to show you another demo here where I'm going to run my SQL Server container and OpenShift cluster. And as you can see, it's very, very easy to get started. So to show you the demo, what I'm going to show here is I have an OpenShift cluster which is created. Again, this is an Azure Red Hat OpenShift cluster which is created. And what I'm going to do is I'm going to run SQL Server on top of this OpenShift cluster. And to do this, the first thing that I need is I need a way to connect to my OpenShift clusters. And as you can see here, these are the commands that I have. I first get my credentials and then put in my credentials here to be able to connect to my SQL Server. Sorry, not SQL Server, but OpenShift clusters. So if I go ahead and run a simple command get all, it should get me all the resources that are currently running on my cluster. As you can see on my OpenShift cluster, I have no deployments yet. So what I'm going to show you is I'm going to show you the deployment YAML file that I've created, which I'm going to use on this cluster. So this is the deployment YAML file over here. As you can see, I'm going to go ahead and create a storage class first, then create a persistent volume claim based on that storage class. And then I'm going to deploy SQL Server with one replica set. The instance name or the host name that I'm going to have for my SQL Server is MSSQL deploy. And there are several, and these are the container specific options. For example, I'm getting my SA password from a secret that I've already created on my OpenShift cluster using create secret option command. And then I'm going to run a web edition of SQL Server, which is going to enable the agent, and I'm going to go ahead and get this SA password from the secret that is created. And my SQL Server container is going to run this build on Ubuntu OS. So all of these options, and then I'm going to create a service so that I can connect to my SQL Server, which is running on OpenShift from outside the cluster. So to do this, all I've got to do here is run the command, which is oc.exe, apply -f. I think I have this command ready here, so let me just get it. Yes. So this is my deployment file. I just go ahead, hit enter. This is going to go ahead, create, it has gone ahead and created the storage cluster first. So if I just say get SC, you should see the storage cluster which just got created about 8 seconds ago. Then I also created a PVC. So I can just say get PVC, which is the claim, and you can see the MS SQL data getting created here. And now let's see what all resources got created. So I'll just go ahead and do get all. As you can see now, it has started creating my service. The service is already created, which is running here. The container is currently in container creating status. So if I want to go ahead and look at the description of this, all I've got to do is run this command here. So I'll just copy the name of my container and I will replace it over here. So this is the name of the pod and you should see the container is started. So let me just clear this, go back up top here and just run get all again. So this is an OC cluster, OpenShift cluster. And what I'm going to do is now I'm going to connect to this from outside of the cluster. So I'm just copying this as you can see. So I'll go ahead and connect to this using my SSMS, which is running on my machine, or this is running outside the cluster. Provide the SA password in. There you go. I am now connected to SQL Server. My agent is up and running, and this is a SQL Server which is running on OpenShift, which is running Ubuntu. So if I can just go ahead and do select at version, and we execute this command, you'll actually see this is running a web edition as per my deployment file running on Ubuntu. And all of this is, SQL Server is currently an OpenShift cluster. And now if I just go ahead and also do a server name, there you can see this is the server name that I used in my deployment file over here as well. So all of this is from this deployment file. I was able to get it up and running. Now, let's say that my pod goes down or something happens, something bad happens to my pod. So let's say someone goes ahead and something bad happens to the pod. So all I'm going to do is OC delete, give the pod name here. So this is going to go ahead and delete the pod, and you'll see that automatically after the deletion, it also goes ahead and starts on its own. So we'll just give it a few minutes. Oh, I have to mention delete pod. I forgot that. My bad. So the pod's deleted, and as you can see, I just do a get all again. You should see a new pod already up and running. There you go. So this is a new pod which is already up and running. Let's see if my connection is still working. So let me just go ahead and say, or let me just run this command again. There you go. My connection is up and running. So my pod got deleted. SQL Server was deleted, but because it was running on a container orchestration system, it was able to get it up and running on its own. So the idea is you can go ahead and deploy your SQL Server in a container orchestration system, which has the HA abilities already inbuilt into it, and start using it from the day one. All right. The last part that I really want to cover is about, the troubleshooting part of the SQL Server containers, because when you're going to start in this journey, there is definitely places where you're going to work and, work on the SQL Server containers and see how it all comes together. So this is where I want to talk to you about the troubleshooting aspect of the SQL Server container. Now, if you see your containers are not starting, if there are some errors when you see for SQL Server containers from starting, you can troubleshoot with your experience that you already have based on SQL Server. So the way you would troubleshoot any SQL Server startup, which is by looking at the logs, by looking at the OS logs, all of this is still valid here. And I've shown some of these steps to you in the demos. If there is a connectivity issue with SQL Server containers, the most probable reason that is there is the port that has been used or that has been mapped to your host. That host port is not opened up in firewall or in the NSG if it's deployed on an Azure environment. Or the other reason that I've seen most of the times which impacts the connectivity is that you don't have a host entry in the DNS for the container mapping to the port of the host. So you need to have that DNS host entry where the SQL Server container's fully qualified domain name has a mapping to the IP address for the host which is running that container. The other part, the SQL Server logs, which you are used to, where you see the error logs, the SQL agent logs, the dump files, all of that are located at the location which you can see on the screen. And I've shown you the docker exec minus IT commands in our demos where you can connect to it and start working with it. So with this said, I'm sure this is probably a lot of information, but what I really hope is that you've seen the work that we've done for SQL containers to be now something that you would want this to be running in your production environments. But I am sure that if you would have any questions, you would want to talk to us, please feel free to reach Win or myself on the email address that you can see on the screen, and you could follow us on Twitter, LinkedIn. My LinkedIn information is also available on the first slide, and I'm really happy and excited that we got to share this work with you, and looking forward for your feedback. And if you have any problems running with SQL containers, SQL Linux, please feel free to drop us an email. Thank you again, and have a good learning ahead. Thank you. Have a good one.